Alright, so that's the zero factor theorem. If something times something is equal to 0, then one or the other has to be 0. Now we have to explain why that's a huge deal for our class. It goes like this: solving equations is a big topic in any class. So it turns out that there's a deep connection between solving equations and the zero factor theorem. And the connection goes like this. Suppose we start off with this problem, which is solving equations. Imagine if we could write it in this form. Move everything to one side so that you just have a bunch of stuff here and you have 0 on that side. Imagine if you could do that. Okay? Now next, imagine that you could factor the left side so it looks like something times something is equal to 0. Just imagine. We've been practicing factoring for many weeks now, so this might be doable. Now we could use the zero factor theorem and say, whoa, something times something is equal to 0. That can't be unless the first one is equal to 0 or the second one is equal to 0. And that's going to be key right here. This is where we use the zero factor theorem, and it's going to turn your big difficult problem into little tiny baby problems. And that right there is beautiful. That's exactly why the zero factor theorem is so powerful. And so there's a connection between solving equations and factoring and the zero factor theorem. And all three things together go hand in hand, and then once you understand factoring and zero factor theorem, solving becomes incredibly easy. Anyways, talk is cheap. Why don't we actually do it? I'm tired of talking about it. Let's just do it. So what I'd like to do here is go with the game plan here. Move everything to one side and clean it up. I'm going to clean it up here. 3x squared plus 12x, that would be a negative, plus negative 10, and that's equal to 2x plus negative 5. That's just distributive law and some easy axioms. I distributed here. Definition of a minus b. I changed all the things to plus because I like pluses. Alright, I'd like to get rid of this so I can move everything to one side and get 0. So I'd like to subtract a 2x from both sides, and I would also like to add a positive 5 to both sides. That would put me here at negative 12x plus negative 10 is equal to 2x plus negative 5. Let's go ahead and add that stuff to both sides. We'll go with blue. We're going to add a negative 2x plus a positive 5 to that side, and we're going to add a negative 2x plus a positive 5 to that side. We're going to justify it because that's cancellation law of addition. Alright, let's clean it up some more. Here I have 3x squared. Here I have negative 12x. And here I have negative 2x. So that will give me a grand total of negative 14x, and then I have my constants here. I have a negative 10 and I have a positive 5. Negative 10 and a positive 5 would give me negative 5. And on the right hand side I see I have total of 0 because the things got killed, the additive inverses. And now we have the first part of the process complete. We have something plus something plus something is equal to 0. We have 0 on the right hand side. Keep in mind, what we want ultimately is something times something is equal to 0. So now I'd like to take this and factor it. And so I use all my factoring skills. One of them was splitting the middle term. So I would take the 3 and the 5 and multiply them. And I look at all the different candidates. 3 times 5 or 3 times 5 this way with a negative there. They have to be negative, so one of them has to be negative. 1 times 15 with that negative, or 1 times 15 with that one negative. I believe this one will get the job done. I'm trying to split negative 14. None of these are negative 14 when you add them. So I'm going to go with that. 3x squared plus 1x plus negative 15x plus negative 5 is equal to 0. That's just by inspection. Split in the middle term. I do by grouping. 3 times x times 3x plus 1. I check to see that I did it carefully. 3 times 3x gives you 3x squared. 3 times 1 gives you 1x. So that step looks good. I check this. I think I can factor out a negative 5. That would give me 3 times x plus 1. I checked that I did it carefully by multiplying it. Negative 5 times 3 gives you negative 15. Negative 5 times 1 gives you negative 5. That looks good so far. This is associative law of addition and distributive law, grouping stuff. I have a 3x plus 1 and a 3x plus 1, so I could factor that as that times 3x plus 1 is equal to 0. And now we've done something amazing, because we had this big old long problem, 3 times a number minus 4 minus 10 is equal to 2 times a number minus 5. And now we've broken it up into something times something is equal to 0. A number times another number is equal to 0. Now we use the power of this guy right here. Something times something is equal to 0. That can only be if either A is equal to 0 or B is equal to 0. That's what the zero factor theorem time is. Whoa, zero factor theorem time. So that's what we're going to use here. So we go back to our page where we were. This is where we are solving it. There it is. Something times something is equal to 0. That right there tells us that either x plus negative 5 is equal to 0, or 3x plus 1 is equal to 0. And that's the zero factor theorem. That right there is super, super powerful. Now look what you've done. Look what we've done. We took our big monstrous problem, degree 2, impossible, and now we've exchanged that for a couple little baby problems. Degree 1, super easy, super easy. I can't believe I get paid to do this. I can't believe I get paid to do this. Easy. So here I would add 5 to both sides, and that would give me 5. Here I would add a negative 1 to both sides. That would give me negative 1. And of course I could kill the coefficient. X equals negative 1 over 3. And there are my solutions. Two solutions. Two solutions for a degree 2 problem. Incidentally, you should know that the degree of the equation tells you how many solutions you should expect. That's not an accident. That's no small idea either. It's called the fundamental theorem of algebra. The degree here is equal to the number of solutions. And so this was degree 2, and I got my 2 solutions. It's easy to check to see if we did this right. You could take these and plug them back in here and make sure they work. For example, let's take the 5. Let's check it here. We'll check it in red. 3 times 5. How much is that? I don't know. How much is 5 minus 4? I don't know. But and the question is that the same thing as 2 times 5 minus 5? Well, I'll do the right side here. 2 times 5 is 10. 10 minus 5 is 5. On the left hand side we have oh, I forgot minus 10. On the right left hand side we have 3 times 5 is 15. 15 times 1 is 15. 15 minus 10, well, that turns out to be 5 as well. Told you. So you should check these solutions that they work, or you could if you wanted to, if you're ever wondering whether you did something correctly or not. That would be an option. Anyways, this does a lot of important things. It explains the importance of the zero factor theorem and how the three things are connected. Here, let me explain it again. The three things are connected. Solving. Well, I'm trying to change to yellow. Solving. It's connected like this. First step is you try to move everything to one side until you have just 0 on that side, either side, and you move all the stuff to that side. So if you have numbers here, you can add the negative inverse of them or add the additive inverse of them. The second step is you factor. If you can factor, you're going to be in good shape. If you can factor like this, it's beautiful, because now you have, instead of having a bunch of things added together to give you 0, which could be anything, you have something more specific. Something times something is equal to 0. And that allows you to break this up into little tiny steps. That right there is magical. And so you take your big problem, and through factoring and through the ZFT, you can break it up into little tiny baby problems, just like we did 2 seconds ago. Alright, okay, that gives you the main idea. Come back and we can do a few more examples of ZFT and how that's connected to factoring and solving.